get, so the thing that I say is, if you're a developer, and you gotta enumerate what the attacker might go after, they don't want the row from your database. They don't really care, right? They may want recognition, or they may want to be able to get into DEF CON, for free. They may actually have financial gain. I mean, if I steal your credit card, I can sell it for $50. So there may be an actual commodity market there. But think about what would put your company out of business, or what would get your boss or your boss's boss fired. And those are actually harder problems to answer than you'd expect. So, for instance, working on these phones, right? So what are some of the doomsday scenarios? One of them would be if I could send an SMS worm that would brick every phone, right? I can put a price on that, and we can go after that attack. What in your organization is the equivalent to that, right? Misuse and abuse. If you have, this is like the ghost use case. I'm really not sure why that didn't come out. If you have usage of an application, and so this is supposed to be a use case of someone editing their profile on a networking site, so MySpace or Facebook or something like that. And we're going to start to think from a misuse perspective. That's normal use. I'm editing my profile. What negative things could occur that would be misuse of that same functionality that might be interesting? So if I'm editing my profile, am I allowed to put HTML tags in that are bold that say, I really like this movie? Is that an undocumented feature if that works? Yeah, it's probably an undocumented feature, but what happens if I put script tags in, right? And now we're in a scenario where, okay, well, this is actually code that I'm putting up there, and can that code, actually end up in a type of attack? And so misuses, this slide was animated, but it's not going to work, unfortunately, will be very helpful. The two things that I tell people is the first set of threats you should enumerate for your application are normal users who are doing one of two things. The first thing is behaving as dumbly as possible, right? How could they abuse the interface and just do dumb stuff? Now, when you do that kind of misuse solicitation, you're really starting to drive intelligent fuzz testing, right? Because you're going to start to think about the things that you'd want to actually test in your application that may break it. The second thing is, what evil could they do to mess with the application? So if you think about dumb and you think about evil, you're going to have misuses that will probably drive breaks in your software just from the interface. Another good ripe entity to drive some of threat modeling behavior is the specified security features. When I asked what a good security requirement was at S3, about 5 years ago now, John Villegas screamed, "Use 128-bit encryption." And I thought, well, that's the best negative example I possibly could have asked for, right? So if your requirements documents, if your specifications say stuff like this, then think about misuse and abuse of these things implemented correctly, right? If I'm encrypting something, what was it that I was using the encryption for? Was I trying to protect the privacy of information? Was I trying to prevent against replay? Is the kind of structure I've provided the data I've encrypted going to prevent against replay? Those of you who saw Gunnar Peterson's web services tutorial or talk, he shows very simply how you can start to use security features like WS security and encrypting messages that are still vulnerable to very obvious attacks or more subtle replay attacks. So mining your security requirements for things that are very specific but have nothing to do with what the application's actually trying to prevent is a valuable place to look for places to abuse. And we say at Cigital that software security is not security software. That's actually a Mike Howard quote, so not to misrepresent that. But I'm not sure if it's still the case, but there was certainly a time when we could basically guarantee if we looked at the security requirements for an application, we would have to go no further to break it. So once we've gotten some of these inputs, the who's, what could turn an actor of the system into a misactor, and we've looked at the requirements and mined them for ambiguity, just general being at the wrong level and missing the goals. We have to do what I call really the first step of threat modeling, which is starting to anchor it in the architecture. So let's talk about that a bit. We have to anchor this thing in the software architecture, not just the network topology. And we have to start to enumerate things like the business objects, sensitive data, and privileged functionality. This can't just be about the boxes and lines, and I'll give good and bad examples of this stuff. There are things that business stakeholders and analysts can do in this process, and there are things that developers can do in this process to augment getting each other's skills and get to the right level of diagramming to the point where you really feel confident that you're talking about the technology and the technical risks to it at the right level. I'll talk about some of the things you can look for when you look at middleware and open source and frameworks that are going to be fundamental and interesting to a threat modeling exercise. In my mind, again, the output of this really is just to drive your further assessment of the application and testing. Again, it's the rules of engagement and it's the plan by which you're actually going to test the application. It's just like any design review, right? When you've looked at the application at that level, you've hypothesized that there are vulnerabilities. You don't know that they're exploitable yet. This allows you to agree with the rules of engagement between development and security, to make sure that you've been thorough about enumerating all the things you want to enumerate, to go after, to prioritize them based on risk, and then to establish a tie in the architecture, in the design, between the vulnerabilities and the controls, right? This is really sort of a format for diagramming and design discussion. You still have to bring to the table your security knowledge. You still have to bring to the table your development capabilities and your understanding of the software and its business, its actual goals. And you still have to do the thinking of figuring out what the threats could entail. And so I'm going to jump into an example really quickly, just to mention kind of some of the technical, some of the design discussion that can come from looking at where the assets in your system flow and what's available where. And so when you think about systems and you think about when you think about where information exists in the systems, remember anyone call up tech support to ask for a password reset. Right? This is a password reset, a workflow that every system has, right? And it's an interesting workflow because it's a workflow that's going to involve some sensitive data, right? And it's going to involve credentials to the system. And what's funny about it is when I call tech support and I forget my password pathologically, because I make ridiculous passwords. It's funny when I call these guys up and have the conversation with them, because when I talk to them, I can almost see the interface they're looking at, right? And so, when you call these guys, they always ask you for your name, and then they ask you, are you the guy at Mirror Way? And I say yes, right? And when I say yes, I know that they're already considering that information, because for them to ask me that question, that means that the person in the call center I called, when they typed in my last name, got basically a pull-down box or something, right? And all of you know that, after they've verified that you're the person, right, the particular John Stephen, right, or whomever that